Okay, so let's work out the math of collusion quickly because we've actually already done it because it's basically the same as monopoly. But then let's point out some of the problems with it. And the problems arise because of incentives. And that's really what we're going to talk about in later chapters when we're talking about non-cooperative oligopoly. So we're going to have our same demand curve. So our inverse demand curve is P equals A minus BQ. But now instead of one firm, we're going to have two firms. So firm 1 and firm 2, indexed by I here. And our total cost function is just CQI. And so marginal cost then is just C. And so the profit for firm I is just PQ, that's revenue, minus CQ, or P minus C times Q. But the big difference is that the Q, right, the capital Q, is Q1 plus Q2, right, or QI plus QJ. And so profit for firm I is going to be AQI minus BQI squared minus CQI. That's what we have in our traditional monopoly. But then this extra term minus BQI times QJ. And so profit of each firm depends negatively on how much the other firm produces. And so that's why cooperation is going to be so important in terms of getting to the monopoly output level. So if we think about total profits, right, we're thinking about cooperation, so we want to maximize total profits. So that's just, capital pi, that's total profits, equals pi 1 plus pi 2. That's profits of firm 1 plus profits of firms 2. And so that's just P minus C times total industry output, or Q1 plus Q2. We can just multiply that through, right, substituting in for P with our inverse demand curve. And we get this sort of profit function where we have profits of firm 1. That's just what we had before, AQ1 minus BQ1 squared minus BQ1 Q2 minus CQ1, plus the profits of firm 2. AQ2 minus BQ2 squared minus BQ2 Q1 minus CQ2. And like now you're thinking, oh my gosh, that is crazy. I don't know what we're going to do. We got too many Qs with too many subscripts. What are we going to do? Actually, it turns out it's pretty simple. We're just going to differentiate the total profit function first with respect to Q1 and then with respect to Q2. And what that's going to do is give us two equations with two unknowns. And it's easy because when we're differentiating with respect to Q1, we treat Q2 just like a constant, like B or A or C. And when we're differentiating with respect to Q2, we treat Q1 as a constant. So first we're going to do it with respect to Q1, right? And so we're going to treat Q2 as a constant. We get A minus 2BQ1 minus 2BQ2 minus C equals 0. And that second BQ2 just comes from this period over here, right? There's the only part with Q1 in the second term is this BQ2Q1. And so when we differentiate, we get the minus BQ2, and that becomes the minus 2BQ2 here. And then it's really just the same with respect to Q2 because everything is symmetric, right? So symmetry in math is our friend, makes everything solving a lot easier. When we get equations like these, we call these our first order conditions. First order because we take the first derivative as opposed to the second derivative, which would give us, of course, our second order conditions. We're not going to worry about that. But we have two equations, right? A minus 2BQ1 minus 2BQ2 minus C equals 0. And A minus 2BQ2 minus 2BQ1 minus C equals 0. And with those two equations and two unknowns, Q1 and Q2, we can solve for Q1 and Q2. We can do that a number of different ways. We could say, hey, they're symmetrical, so they're going to be equal, and just call it Q, and then solve for it that way and be like, oh, wait, it's the same as a monopoly. But whatever we do, we're going to get our Q star. The way they do it in the book is they say, okay, let Q star be the profit maximizing quantity, and say Q1 is equal to Q star minus Q2, and then plug that in and solve. Anyway, you get Q star equals A minus C over 2B, P star equals A plus C over 2, and profit is A minus C squared over 4B. These should look very familiar because this is just our monopoly quantity, price, and profit, right? The problem comes because it doesn't say who produces how much, right? The way we had it set up is, symmetrical. So we could say, all right, Q1 equals Q2, everybody does half, you get half profit. But that's not always going to work, right? Sometimes there's going to be bigger firms who are going to demand to produce more than smaller firms, or just depending on what the bargaining power is, some firms might want to produce more. So we have a coordination problem. And how we solve that could be complicated, right? So what do we do up to, all right, if I'm producing half of the monopoly output and you're producing half of the monopoly output, then we're good, except I have an incentive to produce a little bit more because that's going to increase my profits. We're going to do an example in just a minute. But that increases my profits, which means that cartel solution, that cartel collusion is not stable, right? And so the cartel dilemma says that what's in the best interest of the cartel is not in the best interest of the individual firms. And so the cartel has to be able to police themselves. So this graph, I think, is a little bit complicated. Really, all it's saying is that when both firms are producing the cartel amount, which is this Q1C and Q2C, that maximizes total profit, but it doesn't maximize individual firm profit. And actually, what would maximize firm one's profit is to produce over here at Q1 star. And so all this graph is saying is that firm one wants to produce more when firm two is producing at Q2C. And of course, the same is going to be true for firm two. If firm one is producing at Q1C, firm two would like to produce at a higher level. And so that's what's going to take us, after this chapter, into, something like the Cournot equilibrium, where we want to find a mutual best response. But for now, just know that the cartel quantities maximize profit in total, but not for each firm. So here's a quick example. If we set A equals 12, B equals 1, and C equals 0, then we get Q star equals 6. So now each firm should produce half of that, or 3. P star equals 6, and then the profit is 18. But if we plug these numbers in and we allow firm 1 to produce 1 more unit while firm 2 continues to produce 3, so firm 1 is producing 4 and firm 2 is producing 3, then firm 1's profit increases to 20 and firm 2's profit falls to 15. So you can see total profits have fallen. They're down to 35 as opposed to 36, where they were each earning 18. But firm 1 has done better. And so we can think of this really in a game theory point of view, right? Where it really looks just like the prisoner's dilemma. And we have up here, all right, firm 1 can set a price equal to 3 or 4. Firm 2 can set a quantity equal to 3 or 4. If they both produce 3, profits are 18 each. But if one produces 3 and the other produces 4, then the one that produced 4 gets a profit of 20, and the one that produces 3 gets a profit of only 15. And so, of course, we know what will happen. They both produce 4 if this is their choice space, and they end up with only a profit of 16. Just like in the prisoner's dilemma, they do worse off. So this isn't the only problem with cartels, but it's a significant problem. And as we'll see later in the chapter, it means that a lot of cartels don't last very long. Other problems include stricter enforcement and penalties for violators. So that means that reduces the potential benefit of forming and sustaining a cartel. Obviously, you can't take cartel members to court for violating agreements because it's illegal. And detecting cheating can be a problem when there are lots of firms in an industry, right? Especially when there's demand fluctuation. So if demand goes up and firms start producing more, are they cheating or are they just producing more because demand went up? It's not clear. And so there are a lot of problems with cartels, but the extra profits are a big draw, and so they continue to be formed.